Okay, hello guys. Welcome to the MPC micro project session 2. So today we'll be, let me just open up the slides first. So today we'll just recap over what was done last week. Then we'll design, we will look at what we are about to build. Then we'll set up the project in Visual Studio Code. And then we'll go through basic implementation. I'm audible, right? Hello? Yeah, okay. Thank you. So first is the sentence transformers library. It just captures semantic meaning between sentences instead of just matching words with each other. So Neil was explaining this last week, so I'll just go over it. Next one is cosine checking. After converting the sentences into vectors, we need to figure out how similar two vectors are with each other. To do this, we use cosine checking. And then next one is rapid fuzz. This is what we'll be using for searching in our Netflix clone. So yeah, this was also discussed in the previous session. So before we build the next Netflix or a smaller version of Netflix, we first have to design, we have to understand what we're going to build. To do that, we'll go to a tool called Excalitro or any other sketching tool, and we'll jot down what we're about to build. So first, it'll be a website, of course. Then what all features will it have? It should be able to search. We should be able to search for movies with it. Then after searching, there will be some movies which will be listed. 1, 2, 3, 4. And we should also have something like when we select a movie, say for example, we select Batman, we should have movies similar to it pop up. So this is not the best, I'm not the best artist, but you get the thing, you get the point. It'll be something similar to this. The selected movie will be on the top and the movies related to it will be on the bottom. So to obtain this, we need how many features? First, we need the ability to search. So that is what Rapid Fuzz will be providing us. And then we need to be able to recommend other movies based on what the user has selected, which is going to be done with the help of sentence transformers. So now we have some sort of idea on how to build it. Neil has explained the theory behind it. So these are the libraries which are required to build this project. So before we go to installing libraries, I'd like to introduce you to environments. So we can directly go to Visual Studio Code. Let me just create a new project, open a new window. Interesting. Let me assume you can see my screen. File, open folder. I'll open it here. I'll create a folder called MRS2, or you can call it whatever you like. I'll call it MRS2. So yes, I trust the authors. I assume you all have pip, Python, and Visual Studio Code installed on your system. So yeah, after that, I can just go ahead and install all the necessary libraries like pip install, Streamlit, and whatever. But what it will do is it will install it in the alongside the main installation of Python, which is fine if you're only coding one or two projects. But that's not the case. You might be computer science students. You'll obviously be coding different projects which will have different requirements. And sometimes one library in your environment might be conflicting with another. So if one code breaks or if one library breaks, you won't be able to run other projects. Or suppose you want to post the code on GitHub and you want to let someone else try out what you have coded, re-implement it on their system. If you just do pip install without setting up environments and properly documenting, properly having all the packages, listing out the packages, their versions and all that, they won't be able to implement it properly. To do this, there are many solutions within Python. There are package managers. Ven is the most popular package manager, but in this project, I'll be utilizing UV because it's much more easier and it's faster, I think. So to use UV package manager, you need to have pip. So first pip install UV. Pip is also a package manager. So pip install UV, and then UV will get installed. It's already satisfied in my laptop. Alongside this, we're also going to the IMBD dataset. So we also need to do some sort of data analysis, not like really complex stuff, just basic stuff. So to do that, we need a Jupyter Notebook. So we can install Jupyter Notebook inside a virtual environment, but the thing is, Jupyter Notebook is a really large application, so it's better to install it alongside your main Python thing. So pip install Jupyter. You can just type this out and it'll install. I won't be doing that because it'll take extra time. I'll just 1 second. Yeah, Control-V. I'll just send the required commands in the chat so that you may copy paste. So after you installed Jupyter and UV, you need to just type in UV init. This will initialize a UV project. You'll get many files, a gitignore file. I think a .git file is also there, but it's hidden. This is basic Python file. A project is set up for you. And pyproject.toml, this has all the details about the Python version you're using and all that. You can change it, of course. So yeah, that is also there. It gives you more flexibility. If you want to know more about UV, you can just go to the documentation. It's a really cool package manager. It's more than just a package manager. So now I will just copy paste all the required libraries. Let me just UV add Streamlit. So now it will automatically create a virtual environment and install all the dependencies in it. So yeah, we'll wait for it to install. Okay, while it's installing, I'll like to go to the data set. So we need to search for movies, yeah? As Neil might have explained in the previous session, we need a lot of movies. To create Netflix, Netflix has a data set of movies. And to create a Netflix clone, we need a list of movies. There are many movie data sets. I'm using IMBD 5000. You can use anything else. There's like tons of them on the internet. I'm using this because it's a small data set and it will be relatively within the scope of this project. So I can download this data set in two ways. I can set up Kaggle Hub, set up API keys, and just copy paste this code. Or I can use this fancy method called downloading the data set normally as a zip file and hit on save. Hit save. I'll open it in folder. I'll just copy it and paste. No, wait. I'll copy it and paste it to my Visual Studio Code. Reveal in File Explorer and extract the entire thing. I want the folder to be called dataset. So dataset. So interesting. This is not the dataset. Okay, 1 second. Yeah. I accidentally stumbled upon the wrong data set. This is not the data set I was looking for, but sorry. 1 second, yeah. I'm sorry, this is the data set we'll be working with today. Sorry for the inconvenience. I'll be sending the link of this data set in the chat too. Okay. So I'll download this data set again. Save as. I'll save it within desktop, MRS2, proper data set. I have the data set. I'll delete the wrong ones. And I will, where's the extract button? I'll extract all into a folder called dataset. All right. Now, this is a dataset with 5,000 movies. It has movie titles, genre type, and all that. If you want, you can do data analysis on it with Excel, but we are computer science students, so we'll use Python. Yeah. So if you want to do data analysis, you can use you can create a file called test.py or whatever, or you can just directly code in here, come in here and start typing df is equal to import pandas as td, df is equal to read CSV data set dot, what is the more interesting name? Let me just copy the name and dot CSV and then print df head and go through the data set like this. And after that, I'll hit on run. The thing is, I'm using double backslashes because I'm on Windows. If you are on Linux or Mac, you will find the file like this. So since I'm on Windows, I'll use this and I'll hit run. Oh, no, when I'm running with UV, I have to use UV run main.py. Interesting. So I can approach data analysis, understanding the data set like this, but I can also do something which is used. I can also use something which is used by almost all data analysts across the world, which is Jupyter notebooks. So to create a Jupyter notebook, I can just type in any file name and followed by ipynb. And when I create the Jupyter notebook, it'll try to detect any environment in this subfolder. So let me try to import pandas. Pandas is, when I try to run it, one second. When I try to run it, it'll prompt me to select an environment, and the environment here is being detected, and I can click on enter. So we have to wait for the thing to be loaded in. So it works. So what was this? So I'll just take this code, whatever I wrote here, and put it in here. Also, one other reason why we're using Jupyter Notebook is, say we perform some analysis, we write some code, some other code, and then somewhere over here an error pops up. And then we write code. All the data which was created up until here, all the variables until here, which was stored in cache, will be destroyed if we run this as a whole. So Jupyter Notebooks help avoid that. So that's one other reason we'll be using Jupyter Notebook. So df.head. So this is the data set, and let me just close up something else. So we have the title. We have many data about the movie. So the df.head prints the first 5 rows of the data set. Okay, now what do I need to do now? One second. So we'll go back to our, what do you call, small visualized diagram. Now we need to understand the features that we require. First one is rapid fuzz. We need to be able to search for the movies. So to do that, we'll create a function for now. How functions work in Python is we write def and the name for the function, function1, and we pass in parameters. Parameters are like values you pass into a function, say name, then return. I can print something. with the parameters. I can use the parameter within the function. So if I say if I call the function with the parameter, I can use it like this. So now I want to do something like, I want to search a title and through a list of titles. So I have title, then I'll also pass in a list of titles, which I can get from this data set. There is, I'll just show you that first. Data frame, and there's a thing called title. There's a column called title. So when I press enter, all the titles of all the movies I can get. So then I can do something like, for I in titles, if title is equal to I, return true, which means that if I search in avatar, and if avatar exists in the list, which is in the data set, the function will return true, otherwise it will return false. But we do not want that. That's useless. Neil already discussed that. We want rapid fuzz. So to do that, I've already coded it out because I cannot, by heart all the code which is required. So rapid fuzz is a library which is used to do fuzzy logic operations. Then we can use search movies is a function which takes in the parameter title and the list of titles, and limit is 10. It's basically constraining. I'm putting a constraint on the number of results which are returned. This is not required. So now this is the main magic function. All right. So you might be asking, am I doing anything if I'm just importing libraries and calling it? To be fair, you're not doing all the math behind it, but you're building the application. If you're looking at things like, oh, you want to write every single line of code, you won't be doing anything. I mean, you can write code in assembly. Yeah? It does not matter. There's a thing called abstraction in computer science, which allows you to write only high-level code. You import a library and you just use the functions. So that's precisely what we're doing here. So we extract the results from the thing, and we'll do fuzzy logic and compare the title with the list of titles, and we'll provide with a weighted ratio. This is the method which is used, and yeah, we return the results we also make it we'll also make all the titles in the data set lower, because the scoring mechanism does not account for that. So yeah, now I'll give an example of this. I'll define a list, car, bus, caterpillar, this thing, and I'll search for cat inside okay, I did not hit enter on this block. So I get a similarity score for everything. So now instead of searching for cat, I will search for a movie using this function. Search for Batman. And what is the list? The list is the column called title, column with all the titles, yeah? It's not search, it's search movies. Yeah. So this returns all the movies which are similar, which have a similar title to Batman, and this is accurate. So it works. So rapid fuzz is somewhat done. Yeah. So now we go to the next one. So you might be wondering why I might have hinted at this part. Yeah. Why is it there Why is the lower part here? Why am I converting the title into lowercase? I'll just show you the results without that results, and you'll understand. So I search, Batman comes, it's fine. Let me search up cars. No, without title.lower. Okay, I remove all the lowercase transformation, and I'll search for the movie Cars. It works. But what if I change cars to smaller case cars? It does not work because the rapid fuzz algorithm does not account for, it treats capital C and small c as different characters. So it does not work. So in order to fix that, I've used dot lower, and I've converted the results into lowercase as well. Yeah. So now when I search cars, wait, let me just update the code. Now when I search for cars, cars show up. Wait. Search movies. Wait, what? pf.title to list. Interesting. Let me search a different movie. Batman. I hope it still works. Yeah, it works. It's interesting. So wait, I'm converting the string to a lowercase string. And all the titles are also converted to lowercase. But however, it's not working. It's interesting indeed. I think it's aligning this with this, but it's not supposed to happen, but it's happening. So we'll assume it works for now. We'll come back to it later after we, we finish making the transformer and all that. Yeah. So the next one is we need to convert all the rows in the data set to what? To embeddings. That is what the sentence transformer library does. Yeah. So from sentence transformer, import sentence transformers, then I'll create the embeddings. So basically, the code for this is basically from this website or from their official documentation. We use the model. We encode sentences will be a list of sentences. We'll use this model, which was given by them, to encode the sentences. And I will mention my device as CPU. Otherwise, they'll assume that I have a GPU and it'll, the cell won't run properly. And then after that, I can encode the sentences. The sentences are what? The sentences are the, the stuff related to the movie. So if you look at the documentation code, each sentences is like one sentence. So for each row, we cannot just pass in like multiple columns. we have to concatenate the columns, such as we can need to concatenate overview and stuff like genre and all that. So we will concatenate it. Embeddings is equal to df.title. Now, instead of doing that, I'll create a function for what do you call it? Embedding. Def create embeddings sentences model is equal to it's exactly the same code as this, encode sentences. Then I will return the embeddings. So now after this, I think this code will, okay, I forgot the syntax. It'll take some time. So while we wait for that, I'll explain how to concatenate the, what do you call it? The columns. So if you look at the data set, I'll bring it down here. No, I can't. While another block is running, I can't execute another block. So the budget, the link to the movie page, the ID, the original language, the popularity metric or whatever does not really contribute much when figuring out if one movie is similar to the other. So what actually contributes much is the genre. This might contribute. The keywords will contribute. The original title might contribute, but not much as the other words. We can include it. The overview might contribute. The, what else? The tagline, maybe, maybe not. So the art of figuring out what matters and what does not matter is what a data analyst does. Since this is a simple data set, we'll assume only some of these column matters. So I'll just take in the code from here. So I'll create a new column called sentence with title, overview, and the list of genre. I'll also add the keywords because it is also relevant. Yeah, it also captures semantic meaning of the movie. Interesting. Should have finished by right now. Okay, it's fine. I'll think converting the vector, converting the sentence into a list instead of a data frame might have something to do with the code running here and the code not running properly there. So I'll just copy the code directly instead of copying from the documentation. Sentences. So now I'll wait again. So this is the new sentence that we'll pass on to this, function. So after we create the embeddings, we don't want to create, creating these embeddings takes a lot of time, even for 5,000 movies, unless you have a GPU or like a really good computer. Unfortunately, I have a ThinkPad. So converting it takes a really long time. So it took like 2.5 minutes. So I can create embeddings. I can import a library called Pickle. And what I can do is store these embeddings inside this binary folder. So to do that, I'll type out with open any folder name I want to write. So I'll call it embeddings .pkl, which is the file format, and read and write. So as whatever you can write. This is giving a variable to the file you're opening. So as X is also fine. And pickle.dump is how you dump the variable into the binary file. So embeddings is the variable that we created, that we returned the embeddings to. So we'll just do embeddings to X. And this should create the embedding for the entirety of the data set and pass and store it inside a folder named embeddings.pickle, which will appear. Instead of running it for all 5,000 5,000 rows, I will first run it for first 5 elements, like first 5 elements of the data set, to ensure the pipeline is working. It works. So I'll just set it to run for 2.5 minutes. Okay, sorry. So while that's running, I'll just set up my second screen. I can look for. Interesting. So I think it crashed. Why did it crash? It worked exactly. It worked fine while I was doing it with 5 this thing. 1 second, yeah. And move back to CPU, show progress. Create embeddings for the sentence. I'll try separating this into different blocks. Or for now, I will just I'll take a pre-trained model, pre-trained embeddings.pkl, in which with which I've which I've trained before, and I'll replace it here. It should work. By the end of the session, I'll send the entire working code to you via GitHub, so you can try it on your own. This should work. It just happens that my laptop is not that strong and kind of slow. So yeah. And to write these embeddings, after you created the embeddings, we can write the embeddings by importing pickle. I have the code. We just cut it and dumping it into a pickle file. Since it did not work out properly, I'll try to load the pickle file with open embeddings.pickle, embeddings.pickle, read binary as X, and emb is equal to pickle.load X. So I'll just print out what we took from the binary file I dragged from my previous training. It's just tensors, yeah? Because over here, we told it to convert the embeddings into tensors. To show to you that the output of this is exactly this, I'll just train this on a smaller model as I did in the beginning and print out the embeddings. So there's like 5 elements in df.head, and I've created embeddings for just 5. I'll just print out those embeddings. So it's almost same. So, but this one has embeddings for every row in the data set. So after that, we have to use these embeddings to get similar movies. Say, assume a user has a movie X, Batman, and if we use a selected Batman, we need to show the user movies that are similar to Batman. So in order to do that, we have to we'll create a function called similar movies. And what all do we pass into it? So if a user selected Batman, we can just pass in the index of the movie Batman. Index as in when you write df.head, each movie has an index associated with it, yeah? df.head, each movie has an index associated with it. So if I write df.title 5, this will give me the movie which is in title 5, which has the index 5, right? This will give me the title of the movie at index 5. So to get the similarity, I just need to pass in the index. So def similar movies, I'll define the function again. Index of the movie which is selected Then after we, open the pickle file and imported the values, I can just pass in embeddings, which was saved as EMB here. And then how many similar movies do we want? We'll create we'll say phi f is like k is equal to 10. Like if they do not, this is the default variable. So if k is not mentioned, we will assume k is equal to 10. Okay. Let me just turn off the... Okay. So in order to find out similar movies, we need to have a function which is able to find similar vectors. So we have the index of the movie which is selected. Say, for example, 5, which is Spider-Man. And we can just, we can also obtain the, exact vector of the selected movie by just printing out this. So this is the vector of the movie. And we need to find movies which has a vector which is similar to this. So to do that, we can import a library from scikit-learn called cosine similarity. We can import a function from the library scikit-learn, which we installed in the beginning, called cosine similarity. So it goes something like this: metrics dot pairwise. You don't have to by heart this; it's just basic import cosine similarity, and then I'll just write the embedding of the movie is equal to the embedding of the movie at index I is equal to movie embedding is equal to embed emb dot I at index, and I'll just print the embedding for now. I'll just print the movie embedding and see how it looks like. So I will call the function similar movies for the movie Spider-Man, because at index 5 we know the movie is Spider-Man. So similar movies to Spider-Man. Okay, embeddings is AMB. So this is the tensor for Spider-Man. But the thing is, this is, let me also print out the shape of the tensor. So shape. It's 384. But the thing is, when we are comparing it, we need to have the size, we need to have it as a column vector. So right now it is a, it is a row with 384 columns. So that is what we have right now. But we need to convert it into a column. No, we need to convert it into a vector with 1 column and 384 rows. In order to do that, we will import a handy math library called NumPy. And we can just reshape this with 1 minus 1. And let me print movie.shape again. So which will be 384. So it has 384 rows with 1 column. This is how vectors are represented in embeddings. And this is how we can find out the similarity with other movies. So now we need to find out movies which are similar. I'll just comment the shape out. So similar vectors is equal to cosine similarity. Let me just cosine similarity, the embedding of this movie with the with we'll also pass in the entire embedding the entire embedding of every data set, and that should provide us with movies that are similar. And then let's see what it will just print out similar V and see what it produces. Yeah. Oh, it gives, let me just similar movies dot shape. It's here, sorry. It gives a vector with 4,800 columns, 4,800 rows. That's interesting. But we don't want it in, what do you call it? So it's working, yeah? We have 4,800 rows, which is the amount of movies we have. So we don't want it in column format anymore. We don't want it in vector format. We want it in a normal, what do you call, row format. We just want 480. We just want a list with 4,800 columns or however. So we can just perform a flatten operation here. Now we get this, yeah. So when we print out, this is the similarity between Spider-Man and the movie Avatar, right? Because this is the movie at the 0th index. So and so till the final movie. So there's no point in getting the similarity score. First, we need to find out which movie has the highest cosine similarity, yeah? In order to do that, we need to perform a sort operation. But we don't just want to sort the similarity scores. We also need to keep the indexes. So in order to keep the indexes, we perform a special sort using the NumPy library called argsort. So similar indices is equal to np dot numpy dot argsort similarity similar vectors till this will sort all the movies with the indices. So I'll also do without the indices. I'll perform similarity sort by just equating this into similar v dot sort, which will sort these values in ascending order. All right, I'll just print both of them, similar indices and similar sort. Print similar sort. Interesting. But from here we understand that we're getting the indexes, yeah, indices. But the problem here is the indices we're getting is in ascending order, not in descending order. So in order to make it in descending order, so I'll show it to you. So if you look at the similar indices, so this is 4654. The movie at 4654 is apparently the most related movie to Spider-Man if you're going according to this. So what is the movie at the index 4654? We can just search it up where title 4654, which is Inc. I don't think it's related to Spider-Man in any manner. But whereas the movie at index 5, the movie at index 5 is Spider-Man itself. So we'll ignore that. It's the same movie. At 30, it's Spider-Man 2. At 38, it's probably something, or The Amazing Spider-Man 2. So these are movies similar to Spider-Man. So the movies, the indices towards the end are movies related to Spider-Man. So we want the indices to be in the opposite order of what we have right now. So to do that, we can just do -1, and we get the movies in ascending order. So we reverse the string, right? Also, we do not need all 4,800 movies. We could also do with trimming the movies into a smaller size, trimming the number of indices into a smaller size. So we can do something like the first 10 numbers. Yeah. Oh, we took a value k, so we'll just put k. Interesting. Did not work. I'll do 1 to k. Similar indices is equal to, I forgot to update the value of similar indices, be equal to similar indices. Okay, so these are first 10 movies which are related to Spider-Man. So we'll just check, we'll just confirm if it's equal to Spider-Man. If it's related to Spider-Man, superhero movie. Yeah, fair, it works. So we get similar movies that also work. So let me just create a function. So where when what do you call it? It also prints out the title of all the similar movies. So for I, let me just do a confirmation check. For I in similar movies, Spider-Man is at 5, yeah? Embedding this EMB, I want 20 movies which are related to Spider-Man. Print TF, not print TF title I. So I'll X is equal to, why is this not working? When I put X is equal to similar movies, so this is the value, X dot length, sorry. Oh, I'm not returning the similar indices. I'm printing the similar indices, which is not what we want. Okay, so I'll just return the similar indices, and I think the code here should work. So these are the movies which are top 20 movies which are related to Spider-Man. So we have the similarity with sentence transformers, and we also have the rapid fuzz, albeit I think we need to troubleshoot that, yeah, as promised before. So I'll compare it with the code I wrote before, which was working really well. So rapid fuzz, this is weighted ratio, limited search movies. Interesting. It works. str.lower. So okay. The thing is, the list we are passing to search the movie is not the list of titles, yeah? I'll demonstrate it here. The list of titles we are passing is, it's not lowercase, it's all uppercase titles. So we are not, we're comparing smaller case Batman, which is being transformed here, to the uppercase Batman. And it's not, it won't work all the time. It did not work with cars, yeah? So we have to create a new list, or we have to update this list into a lowercase version of the title. So we'll create lower is equal to lower title is equal to str dot lower and okay, now let's print out lower title. So it's basically all the titles but the sentence is lowercase. So instead of passing the list, I'll pass in lower title. Batman works. Cars works. Cars 2, smaller case works. Cars works. So yeah, everything works. It was just I modified it here, but I forgot to modify it. So yeah, troubleshooting in Jupyter Notebook is also an easy process compared to troubleshooting in what do you call main.py. You can understand, in a Python script, so you can understand where you went wrong and all that. So we have the functions required for the search for finding the similar movies when a movie is selected and all that. Now we'll work on creating a Streamlit UI, not a complex UI, a simple UI. So I'll go to main.py. So first I'll import Streamlit. I think this Neil briefed on how to create Streamlit application. I don't want to type Streamlit again and again, so I'll just give it a keyword as str. No, str is bad. st is fine. So what are the functions we need inside Streamlit? We need pandas because we need to search the movies because what is the function which we use to search movies? Rapid fuzz. Rapid fuzz makes use of pandas. So where is rapid fuzz? So search movies makes use of pandas, rapid fuzz, process, rapid fuzz. So I'll just import those libraries, import pandas. Then I will read the dataset, read df pandas dot read CSV data set. This is the movie data set. Okay. .csv. And then I will create a lowercase list of titles as we did here. Now first, I'll define this function. Just do it like this. Then I'll create lower titles is equal to, what is the definition? df.title, a string lower. And then this is the function we will use when we need to search for a movie. Then what else? We're not creating the embeddings right now. We'll just be obtaining the embeddings. We'll be obtaining the indices of the movies from the embeddings. So we won't be creating embeddings. We'll just be opening the embeddings.pickle binary file. Oh, while we're doing that, let me try recreating, rerunning the code of creating embeddings. Yeah, create embeddings. I'll try creating the embeddings for the entire data set. Again, so we will be opening the embedding file as X. So we need to import pickle. After that, we need to have the function to get the similar movies given an index. So yeah, this was our function from the Jupyter Notebook. So I think that's done. But how is our function coming along? How is our... Oh, it's going on. We'll try writing the code for the Streamlit by the time it's done. So after that, we have all the functions which we require. Now we need to create, we need to add what do you call the Streamlit components. First, we'll add a title. Streamlit.title is called Next Netflix. And then we need to have a field, a text input text field. So what are we, something, I'll name the variable search. It's a text input. So text input is equal to search for a movie or whatever. A movie. So if there is something in the search bar, we will call the search movies function, which will be, where is search movies function? No, we return two, what do you call it? Two values. This function returns two values. So search and the data frame, not df, I'll call it s_df is equal to search movies, and what is it? The title is the search query. So search, and then I'll be passing in the list of lower titles. Lower titles, okay. Then after that, if there should be some results, so I'll just have something called results st data frame. I'll have add a data frame with which is SDF. I don't want everything of the data frame. I just want the title and tag or something. So I'll have that title and is it called tag? 1 second. Tagline. Tagline. I want these two to be displayed. After that, I want what do you call a select box to select a movie. So selected movie is equal to st.select box. Select a movie. And the list of the movie will be the titles. And we'll convert it to a list. Yeah. And we'll also create a button, which if clicked, st.button recommend movies. Meant if the button is clicked, we will find out the index of the movie. Index is equal to tf dot tf title is equal to the selected movie. Selected movie is a list of titles, so selected movie. So among the title, if the title is equal to the movie which is selected, we will obtain the index of that and we'll pass it on to the function similar movies. Yeah. Then after that, similar indices, similar movies is equal to, this is a function, we'll call it something else, similar, function name, and the variable name was colliding. The similar movies, how many variables? It returns one variable, which is an array. So similar movies, index, and embeddings. And where is embeddings? We opened the file. We call it emb itself. So the same thing. I want it to return 12 similar movies. So yeah. Okay. So I'll have a subheader, and there's no need for a subheader for in similar movies, in similar, which is what the similar movies thing returned. the function similar movie is returned, we will print, no, we won't print it directly, we just write it out. St write, we do not return anything other than the index, yeah? Yeah, we'll see that. We'll also return the similarity score later, but for now we'll just return the movies. So first we just f string df data frame and locate I, and we'll print out the title of the movie, and yeah, that's it. We'll also add a text since it's an f string. I think this should work. So I think our what do you call, embedding model failed again, unfortunately. Interesting. Float object. Let me compare it with my code again. No, it's supposed to work. Okay, I forgot this copy paste code exactly. I think it's because I forgot to paste device is equal to CPU. Yeah. Okay. When that's running, I'll just Control J to open up the terminal. Since we are using UV and the environment is not active in the terminal, I'll write UV run streamlit run main.py. A streamlit application opened up. So if I select the movie Spider-Man 3 and click on recommend, it's running. So these movies are being recommended. When I search for a movie, say for example, Cars. Okay, I wrote tile instead of title. Okay, now let me just fix that real quick. Search for movie title. Interesting. One second. I think I'll just give up on writing the code my way. It's fine. It's working. Great. I can't seem to alt tab for now. My laptop is stuck. I'll just stop the process and try. Okay. Okay, let me just stop presenting. I'll go through all the codes after I finish the demonstration. After the Sun 35, I think Arushri is still here. Yeah, I'll go through the entire code after I do it again. Yeah, second. Sorry guys about that. My laptop just crashed. I just go back to what we were doing and I'll run the code. This was the code. So this was the Streamlit code that we were doing. So UV run, because we are using UV package manager, Streamlit. You can see and hear, yeah. Streamlit run main.py, because that is where the Streamlit page is being coded. And it'll take some time. I think it'll load in 2 minutes. So I assume you can see the browser as well, yeah? Hello? Thumbs up or any response. Okay, thank you. So the Streamlit website is loading. Okay. So this, as we coded before, if we want to select a movie, I'll select Iron Man 3, and 12 movies related to Iron Man 3 will pop up, should pop up if the code is correct. It's loading. So yeah, Iron Man 2, Man of Steel, Avengers movies are popping up. I'm not sure about these two, but the model thought these were similar to Iron Man 3. So that's why it's giving these. So now we'll also make sure our rapid first search function is working. So we'll search for cars. We'll search for cars in lowercase because it didn't work properly when we did it during the first time. So cars 2 pops up. Cars 3 does not pop up, but I don't know what's that about. But yeah, it works. Cars pops up, Cars 2 pops up. Or Cars 3 might not be in the data set itself because it's an old data set. So yeah, that's it. Are there any question, or before I go through the data, go to the entire code once more? If anyone has any questions, please raise them. I'll just go through the notebook again. Are there any questions? If there are no questions, please put a thumbs up so I can just go through the go through the notebook once again, and as someone asked in the chat. So I assume there are no questions. Okay, so I'll just go through the notebook, which is where we did the testing and all that. So first we import pandas. Pandas is what most data analysts use to read data sets inside Python. And I'm using relative file addressing because my dataset is in this folder, in the main folder within a folder called dataset and with this name. Since I'm using a Windows system and the file naming convention requires subfolders to be marked like this. If you're using a Linux or Unix, Mac or something, you will write the code like this instead of this. So there's this df.head is df is short for data frame. So when we read a CSV file using pandas, what is returned is the return data type, which is the one you're seeing here. This thing is called a data frame. So that's why, hence the naming convention df. df.head returns the column names and the first 5 elements, first 5 rows within in the data set. So this is how you define a function in Python. So a function names the parameters you pass to the function, and this is, you can use the parameters within this function. And then you can also return something. So return name. Here, instead of, I can assign x is equal to func1. It does hello world. And then if I print x, world gets printed. So after that, df.title, this is how you access a column in a data frame. And then the next is rapid fuzz. This was the method that is used to search, which was mentioned by Neil in his in the introductory session, which was conducted last week. So basically, rapid fuzz is a library which contains a lot of code, and all the complex math has been, simplified, and we just need to import it and use it. So this is a function within the rapid fuzz library, which we are calling. So this is this function definition, how to pass the parameters to the function, and all are mentioned in the documentation for rapid fuzz. So what I'm passing here is title. So if you know the lowercase, so this is title. This is the title of the movie I want to search. I'm passing it in lowercase. Why? Because if the titles are not in uppercase, lowercase, fuzzy logic will categorize small case c as one and uppercase c as different one, as you might have seen when we tried to search the Cars movie. And then we are returning the results. The results will be, what do you call it? Indices, and no, the results will be the sentence, the similarity score, and what was the third one? I forgot what it was. It'll be there in the documentation. I've mentioned it in my reference code. I'll just go through that and check. MRS similarity score, and I think this is the index of the movie. Yeah. Then after that, we also discussed converting an entire row into a lowercase. If you want to convert the actual column into lowercase, I will have this variable over here instead of creating a new variable. But since I don't want to manipulate the actual data set, I did not do that. Data frame, I did not do that. Then the next one is, this is actually trying out the function we defined there. Then after that, we use sentence transformer. Transformers is the technology which is used in ChatGPT and all that. And it's used to create embeddings and find similar words. So to find movies which are related to each other, we want to convert the sentences into a movie, like the data associated with a movie. As you can see in the data frame, there is genre, I'm not sure how to pronounce it properly, keywords in a movie, and a keywords overview of the movie, maybe the tagline. I'm not sure. It's the tagline seem vague, so maybe not that. And combine it and convert into a numerical representation. So we need a method to do that, and transformers provide that. So sentence transformers is a library with a bunch of code, and I think as I showed you here, they gave us a sample code on how to use the embedding model, and I just simply replaced some of it so that my system won't crash, but unfortunately it did. So yeah, that is sentence transformers, and I converted. This is not the code we wrote. This is my reference code. So 1 second, let me just go back to the code we wrote. It crashed here. So basically, I'll pass in the movie vector, movie sentence, which is basically a combination of the title, the overview of the movie, and the genre. We can also have the keywords in here because that is also an important metric, and it will convert the sentence into a vector with multiple dimension. And after we convert it into a vector, we can store it into a, what do you call, binary folder using Pickle. Pickle is a library which helps us create, edit, manipulate binary folders. So we're just using it to load and dump binary files here, but Pickle is a lot more powerful than just that. And then we imported the binary file we stored. We did not store any binary file today because my laptop could not handle the load. And after that, we used the cosine similarity function, which is again from a library which is really popular among machine learning experts, and it's still used, called scikit-learn. And we use this cosine similarity function to find which vectors are similar to the vector which we selected. And yeah, that is it. We made a simple UI using all the functions we created in Streamlit. This UI is not that user-friendly or intuitive, but it has the core functionality of Netflix. This is like a prototype, you might say. So in the next class, in the next session, we'll be discussing how to make this user interface more effective. And instead of just selecting a movie, we will also have something like a user, say you watched a movie, you watched Spider-Man. We'll put that movie into your cache so that you will, instead of selecting one movie and hitting recommend here, when you open up the application, movies will be automatically recommended to you based on what you selected before. Also, the search will be the exact same because there's nothing to change. And yeah, that is it. And the user interface will be a lot better. We will build upon what we have now and make it beautiful. So thank you for attending this session. I hope you all learned something. Bye bye. Any questions? I assume that's it. Yeah. Thank you very much for joining.